Good morning, everybody. It is 9 o'clock. We're going to go ahead and get started. We're going to go over this warm-up, and then we're going to talk about CPCTC, which is going to be just taking everything we've done so far and just adding one more step to the end of it. I think you guys will see that it's pretty basic. So let's go ahead and go over this. As always, guys, make sure that if you have questions that you use chat, right? You can send me a private chat and no one else will see it, or you can use your microphone to ask questions as well, okay? So going ahead here, sorry, I'm just gonna unfreeze and move this down. So again, we're gonna be doing 5.7 today. We'll talk about that in just a little bit. Okay, so we're gonna go ahead and first talk about what are the 4 ways to prove triangles congruent. So this is really important because we're building off of this today. So that is SSS, SAS, ASA, and AAS. So make sure you guys have those down in your notes because we're gonna be building off this today. So this is really important that you guys have this and that you've been doing the homework and know how to do those, right? All right. Speaking of which, you do have homework after this class. I'm really sorry about that, but the practice is important, okay? So make sure you guys, what I would do is just work on it today so you don't have to worry about it over spring break. I almost said winter break, okay? Make sure you guys are turning in all your missing work. So spring break is a good time to get caught up, especially if you're not doing anything. So just as an important note, 80%, right, of your grade is assignments. So 80% of your grade are assignments. Okay. So, and then also remember there's no late penalty. Okay, so there's no late penalty. So 80% of your grade are assignments. There's no late penalty. Okay, so make sure you guys are getting your assignments done. I have office hours every morning, and then the week after we come back from spring break, we'll be going back in person, and then office hours will be changing again. Okay, so make sure you guys, if you need help with your homework that you're asking, you either email me or come to my office hours. We can do the homework together. But remember, your work is 80% of your grade, so you guys need to be turning that in. And also remember, if you guys failed failed geometry A, that you can get credit for all of geometry if we get a C or higher in geometry this trimester. So 80% of your grade are assignments, guys. That means if you're turning in and getting 100% on all of your assignments, then you can guarantee pass all of geometry. Okay, and it's that easy because you can do your work with me during office hours, and so no one should be failing if you guys take the time and come to my office hours. Okay, so we're in this together. We can do this together. All right, and again, if you guys have questions, go ahead, let me know in chat or in by using your mic. Okay, so what are we doing today? So if you're following along in the book, we're in 5.7, and we're talking about CPCTC. Now you're like, what the heck does that mean? Well, what this is what happens after proving triangles congruent. Did I make it? Oh no, I ran off a little bit. Okay, so CPCTC, what happens after proving triangles congruent? Because we spent the last 3 classes talking about proving triangles congruent. So now we're going to talk about what happens after we do that, right? And it's kind of like, well, why are we proving triangles congruent? So we'll have a look at a little bit at that at the end of the class today. But also just remember, the reason why we're focusing so much time on triangles is because triangles are the fundamental building block of all other shapes. All other shapes are made of triangles. And if you guys ever get into like programming or play video games, right? Every single image you see in a video game are actually triangles. Because triangles are the smallest and they're the easiest to render. So they're all triangles. Now, there's enough triangles there that they make it look like they're not triangles, but I guarantee you they're all triangles. And if a game doesn't use triangles, then I'm sure it doesn't perform very well. In fact, I've never heard of a game not using triangle polygon rendering. Okay, so first let's start by figuring out the formal definition of CPCTC. Okay, and then we're going to, then I'm going to go back and I'll give you more of a street definition. Okay, so first, the formal definition. So what we have here is we have corresponding. Okay, so corresponding parts of congruent. Okay, so we have corresponding parts of congruent triangles are congruent. Okay, that is the formal definition of what CPCTC is. Corresponding parts of congruent triangles are congruent. Okay, so again, this is coming after proving triangles congruent. So that's why like the warm-up was mostly just this, right? You need to know this because we can't do CPCTC until after the triangles are already congruent. Okay, so this comes after proving triangles congruent. So this is the formal meaning of CPCTC. Corresponding parts of congruent triangles are congruent. Now, I know it sounds weird, okay, but CPCTC is kind of fun to say, but you guys already use this in your everyday life. You just never called it something like this. So, for example, if you go shopping and you see two products and you're like, are these the same product? Like, why is this product cheaper, right? Especially if you're buying, like if you're in the drug aisle, right? So if you're looking at like pain medication or something, you'll see like a name brand, and then you'll see like a store brand, and you'll be like, well, why is this one so much cheaper? And then you'll look at it and be like, well, are they the same thing? You guys see that, right? You're saying, are these two products congruent? And are you just paying more for the name, right? So that's a way to save money. So in some sense, that's what we're doing here. We're saying, are these shapes congruent? And if they are, right? So for example, if I'm looking at, what's an example? Ibuprofen, okay, is a name brand. Okay, it's a name brand painkiller. But you can go and you can get a generic for much cheaper. Right? So the first thing you do is you look at the ingredients and say, are the ingredients the same? And then if the ingredients are the same, then you conclude that everything else must be the same, that they're the same thing, right? So you look at the main active ingredient. Okay, that's kind of what we're doing here with CPCTC. We're checking our, hey, right, how many parts do we need for triangles can be congruent? Well, we only need 3, right? We only need 3 parts to prove triangles are congruent, right? So if we only need 3 parts to prove triangles congruent, what that means for us, right, and this is the big takeaway, that leaves 3 parts left over. Okay, so there's where we at, right? When we're checking triangles are congruent, we only need 3 parts, right? We have this shortcut. But that means there's 3 parts we haven't talked about, right? And we do this all the time, right? So like another example is if you go shopping for TVs, you might go ahead and you might look at them and be like, oh, these things are the same. They're the same TV, right? You don't take the time to open up the TV and check every single circuit to make sure they're the same TV. Right? Once you have enough information to know they're congruent, we kind of ignore the other parts, unless it's really important. So let's say you're shopping for a TV with your parents, and you're trying to convince your parents to get a new TV, right? And you see one TV at one store for one price, but then you see the same TV for the same price for a cheaper price at a different store, right? Well, you might just be looking at the product number and be like, okay, the product numbers are the same. But then you just want to make sure, like, well, the other one came with all these smart features. Does this one have the smart features, right? And so the idea is you might only look at the product number to say they're congruent, but that means if the product number is the same, right, and they're not lying to you, then all the other parts have to be the same. And that's what CPCTC means. If you have already identified that it's the same thing, then all of the other parts, even if you haven't checked them, have to be the same. So you look at the TV, you see the product number, then you don't even need to check that it has Bluetooth capability because it has Bluetooth capability because we've already shown they're congruent. Okay. Hey, and I'm glad you guys are here that came late, but you guys missed some stuff, so make sure we go back. Okay. So what we're saying here is CPCTC is about the, I'm just going to put this in quotes, the other three parts. Okay, so CPCTC is about the other three parts. Okay, so let me write this out in kind of more street language. Okay, so if two triangles are already congruent. Okay, so if two triangles are already congruent, I'm going to put a little comma there. So if two triangles are already congruent, then all their corresponding parts, so all their corresponding parts are, sorry, I should say, I'm going to get rid of the R. I'm going to say parts must be congruent. And the key here is if two triangles are already congruent. Okay, so I'm going to box this. So if two triangles are already congruent, then their corresponding parts must be congruent. This is CPCTC. Okay, so the formal definition up here in blue, that's the formal definition. But down here, and when I circled in black, that's kind of the street version. This is what you need to remember. If two triangles are already congruent, then all their corresponding parts must be congruent. And you can see in blue here, it says that, just maybe in a more indirect way, right? Corresponding parts of congruent triangles are congruent. The trick is, though, the two triangles have to already be congruent. So CPCTC comes second. It comes second. Okay, that's the big takeaway. So what we're going to do now is we're going to do a bunch of examples of this. Okay, so this is going to be our first example. Okay, we're going to start out with a little Trekkie symbol. Okay, so I'm going to have A, B, C, and D. And then I'm going to ask the question, is angle A congruent to angle C? Okay. Now, I have to throw in some givens. So we're not going to be doing full proofs today or formal proofs today because we don't have a lot of time. So instead of giving a formal proof, we're just going to use a picture and this, okay? But just I want people to know that very easily we could make this a formal proof, right? Because the only thing that makes it formal is you write down the givens, you have a 2-column proof, but we're going to skip that for today. All right, so here's my problem. Make sure you guys have that down. And then we're going to talk about what we're going to do here, okay? And if you're like, Kref, this looks familiar. Yes, it should look familiar. We're using something that we've already proven as a way to ease into CPCTC, right? So we're starting something familiar, and then we're going to add a little bit to it. So that way it's not overwhelming. Okay, so again, we're not going to do a formal proof, but we are going to do a proof in an informal way. So if this was a formal proof, right, we'd make a T-chart, we'd write down our givens, right, and then blah, yada, yada. So the first thing I just want to note is, over here on the right in my notes, I just want to note that we are always proving triangles congruent first. Okay, I just really want you guys to take that away from today. We are always proving triangles congruent first. Now, but if you look at this, it doesn't ask you to prove triangles congruent, does it? Do you see how that can be a little bit confusing? So even though it doesn't say we're proving triangles congruent, we're always proving triangles congruent first. Okay, so that means we're going to have to use either SSS, SAS, ASA, or AAS. Okay, so let's take stock at what we have. I have a pair of angles, and I have another pair of angles, right? So I have two pairs of angles. So it looks like it's going to be one of these down here. Okay, so in chat, what can I find an extra side in this picture? Can you guys help me out? So either give me the reason I can find a side, or tell me the side that I can find that is congruent. And again, we've done this proof before, so hopefully. So in chat, and I appreciate that's a good answer. I need more answers, guys. So right now you're looking at this picture. Where's the pair of congruent sides? What side am I looking at? Or you can say, what property? Give me something. Give me a sign of life. I need, right? I have two pairs of congruent angles. I need a side. So the side is either in between the angles or off to the side. How am I going to get that congruent side? And this can be a short lesson, or this can be a long lesson. But right now I've only had one person respond, and they're absolutely correct. There we go. We're getting more people. Don't put question marks in your answers, guys. Yeah, you're doing good stuff. So again, this can be a short lesson, or this can be a long lesson. But right now it's looking like it's going to be a long lesson because people aren't participating. So that's unfortunate for everyone else. Okay, so good. I've gotten 3 people. So there's 32 in this class. We're working on it. Thank you guys. Thank you. No need to think I think, right? I'm assuming that's what you think. So good stuff. So what's the question? So we're trying to prove these triangles. We're always proving triangles congruent first. I have 2 pairs of angles. So I got to find a pair of sides. So I need to know, looking at this picture, you can give me anything. You can be like, what side do you think is going to be congruent? You can tell me what property do you think we're going to use. You can tell me where to look. Okay, so I need participation. And thank you for asking that question, because that is a form of participation. All right, guys, so I'm a little worried for this. A lot of people aren't turning in homework, and a lot of people aren't participating. So not great, not good. So a lot of people said it. We're looking right here at this shared side, right? So this is going to be reflexive property. Oops, I don't need to write it there. So what I can write is that, here, I'm going to write it in red. Segment BD is going to be congruent to segment BD, and that's reflexive property. Right? Okay. So I do that, and then let's take a look I have. So these pair of sides here, how many angles is this side touching? It's touching 1, it's touching 2. So I look for the one that's touching. So this one, the side's only touching 1 angle, but this one right here, the side's touching both angles, right? Do you guys see how this side's touching both angles? So right there after that, I can say triangle ABD is congruent to triangle CBD, and I can say by ASA. Okay, so what did I do? Always start by proving triangles congruent first. And you'll be like, Kref, but it doesn't ask us to do that. Well, this is the whole point. Even if it's not asking for triangles congruent, this is what we want. So right here by ASA, these two triangles are the same. They're congruent. They're the same TV. They're the same product. Okay? So if these are the same products, now we look at this question. Is angle A congruent to angle C? I mean, they're the same product, right? So should the corresponding parts be congruent? Yeah, they should be. They're congruent. That's what congruent means. Congruent means the same size, same shape. So then so the second thing we do, right? So then use CPCTC to show corresponding parts are congruent. Right? And this comes second. So that we're going to use CPCTC to show corresponding parts are congruent. Okay, and that's all there is to it, right? So we're doing the same thing we did before, and I know some of us need more practice with proving triangles congruent. I could tell because only like 5 people responded, right? And a lot of people aren't doing their homework either, so make sure you guys are doing your homework and asking me for help if you need it. Okay, so if the triangles are congruent, then guess what? Then angle A must be congruent to angle C by CPCTC. And guys, that's our proof. That's it. Right? Now, this is informal. I didn't write down my givens, right? But that's the meat of the proof. That's it. Okay, so if the triangles are congruent, then all the corresponding parts have to be congruent. That's what CPCTC is. Okay? Now, the proof is done. We answered our question, but I do want to point out just a side note, right? Remember, we just said this. There's 2 other parts that we can also talk about, right? So if these triangles are congruent, segment AD, right, that's down here at the bottom, must also be congruent to segment CD, right? And that's by CPCTC as well. Now, we don't need to include this in our proof. I'm just showing you that, like, just because it was asking about angle A congruent to angle C, well, we also know now that these are congruent, right? By CPCTC. And then what's the other sides we didn't use? Segment AB must also now be congruent to segment CB, and that is by CPCTC as well. Okay, so just because we only use CPCTC once, we have to remember there's 2 other parts that we could have used it for as well. Well, that's kind of my intro. Are we doing okay, guys? Does anybody have any questions? Because now we're going to have you guys try these on your own. Okay. And since only 4 people are really having a conversation with me, 4 or 5, you guys can, I hope you guys are doing well, but I'm a little worried because a lot of you guys aren't doing your homework. The people who are doing their homework are getting really good grades because they're getting like 100%, okay, 80 to 100%. Okay, so a lot of you guys aren't doing your homework though. So make sure if you're not doing your homework because you're confused that you're asking questions, you're emailing me, or you're coming to my office hours, okay? And again, it's worth repeating. Remember, if you didn't pass, if you don't pass this trimester, or you didn't pass last trimester, you're going to have to repeat geometry. So if you, right, so we need to pass, or else you repeat the whole year. And if you didn't pass first trimester and you get a C this trimester, you move on, you pass. I'll move your grade up to a passing grade. So everyone should be working hard and doing that. It's a great incentive. So this next one, we're going to try on our own. You guys also have spring break to get caught up, right? If you need to. So we're going to do a bow tie problem. B-O-W-T-I. Okay. Now, this one, I'm going to set it up like a formal proof, but again, we're not going to do a formal proof to this. I'm just going to set it up like a formal proof, and then I want you to just write it out. Okay, so let's take a look. So we have given. So we're going to have that point T is the midpoint of segment AD and segment BE. And we're going to prove that segment AB is congruent to segment DE. Okay. Now we got to be careful here, right? There's two midpoints, right? So this problem, we've done this proof before, right? So you should find this one in your notes. But I just want you guys practicing the process, right? So we're going to do two things. One, you're going to have to first prove that these triangles are congruent, right? You can't just say that they're congruent. You have to prove it. You have to give me evidence. Then after you prove the triangles are congruent, then you have to say, hey, are these two segments congruent? Now, I'm going to give you guys 3 minutes to do this. Figure like 3 minutes is a good amount of time. So I've been stalling a little bit right now so you guys can write down the problem. You know what? I thought I was being funny, so I changed the letters, and then I didn't change the letters. All right, so let's do this. WI and BT, and then WB and IT. That's correct. I'm so sorry about that, guys. I was just trying to be clever, and then I just ended up being an idiot. All right, there we go. So write that down. Sorry about that. And then I'm going to give you guys... Yeah. That was pretty silly, right? You were like, crap, you gave us an impossible problem. Sure did, didn't I? Well, this one's a lot better. All right, so here we go. 3 minutes. We're going to prove the triangle's congruent first, and then we're going to use CPCTC. It's almost like you know how you're going to end, right? Like, you know the answer. It's just how do you get there? And if you have questions, ask me in chat. Do people want another minute? Is that enough time, or do people want more time? More time. Okay. I got you. Let's do a minute 30. And then we'll check back in. All right, check in with you guys. Do you guys need a little bit more time? I can give you just a little bit more time with this, but then we got to move on. So is that yes, we need more time, or no, we don't? Okay, let's go over this. So, you know what's really good about trying problems on your own is that you figure out where you're getting stuck, right? Because remember, I'm not expecting anyone here to all of a sudden be like a proof God, right? Like, that's not what we're going for, okay? What we're going for is you have to try this on your own because you have to figure out where you're getting stuck and what's causing you to get stuck, right? Because then that's where we can be like, oh, I don't want to get stuck there again. So, first of all, we need to figure out what our givens say. So T is the midpoint. So, oh crap. I didn't fix that. O is the midpoint. Oh my gosh, guys. I tried to be so funny with the bow tie. Thing, and then it backfired just miserably. I'm so sorry, guys. Yeah, I'm so sorry. Well, it didn't make sense for T to be the midpoint, right? Because T is way up here, right? Like that didn't make any sense. O would have to be the midpoint, right? So if O is the midpoint of WI, well, let's take a look. Here's WI, right? Okay, so if O is the midpoint, then that means then either side of it have to be the same, right? So that means segment WO would have to be congruent to segment IO, right? By definition of a midpoint. Well, I really dropped the ball on that one, didn't I? Okay. All right, and then it's also in the midpoint of BT. So if O is the midpoint of BT, right, then either side of the O on BT have to be congruent, right? And I'm going to use a different symbol because it doesn't say they're all congruent, right? So I'm going to say, all right, so segment BO is congruent to segment TO, and that's also definition of a midpoint. Okay. So we got two things there. So if we're trying to prove these triangles congruent, right? If we're trying to prove these triangles congruent, what do we have here? Well, we have a pair of sides here, and then we have a pair of sides here, right? So I have two pair of sides. So looking at this, right, I always want to do the easiest. Well, the easiest would mean either I find another side or I find another angle. Well, I'm trying to prove the other side. So I can't do that, right? Because I'm trying to prove the other side, so I can't use that to prove that triangles are congruent. So SSS is out. So I'm going to try for SAS. So do we see, and the angle has to be in between those two sides. So the only angle in between these two sides are these ones. So what property would prove these angles congruent? Can you guys tell me in chat? What property would prove these angles congruent? No, you're right. Don't say oh. Okay, what angle relationship would these two be? Ooh, and be careful, right? So I think reflexive is a really good idea, but what are they really sharing? Are they sharing the angles or are they sharing the point, right? So they share the point, but we're not looking to say the points are the same. So in this case, what I'm looking at, right, is I see an X in the middle. So we're going to say vertical angles. So that is that this angle is congruent to this angle, right? So we're just going to do one of the angles. So BOW. So angle BOW is congruent to angle TOI. Okay. And that is vertical angles. Right? So I get an A here and an A here. Whoop. Okay, so then now let's take a look. Do you see how this angle's in between the two sides, right? The angle's touching both sides, just like this right here. Okay, so in that case, we've proved the triangle's congruent. So I can just use the same lettering here. So triangle BO is congruent to triangle TOI, or TWI. And that is by SAS. Okay, so the triangles are congruent. We always do that first, right? So we always prove triangles congruent first. Okay, we always prove triangles congruent first. Then at the end, okay, so now we know these triangles are congruent, right? These triangles are the same. So are these two corresponding sides the same? Is WB congruent to IT? Well, yeah, they have to be, right? The triangles are congruent. So we can end this with saying segment WB is congruent to segment IT, right, by CPCTC. Okay. Bow tie problems, by the way, always have vertical angles in them. So if you saw, you're like, oh, I've done this before, it has vertical angles in it. Bow ties will always have vertical angles. All right, well, I ruined that problem by trying to be funny, and so it just goes to show you that math shouldn't be funny, and we should just all not have a sense of humor. That's the lesson I learned. Yeah, I agree. All right. Does anybody have questions about this? Anybody want me to go back and re-explain something? We doing okay, guys? Sorry about the confusion about midpoint. That was pretty dumb. Nope, no one wants to say anything. You guys just want to watch me talk. You're like, Kraft, I'd rather this just be a YouTube video. That's weird. You guys are weird, especially like in your generation when like Twitch and stuff. Don't you guys like saying stuff in chat? Okay. Well, let's do another try on your own. And then at the end of this, we're going to do a real world example. Like, why would we want to know this? Okay. So we're going to do another type of bow tie problem. Okay. We're going to call this ATE and CD. And we're going to have given that segment AT is parallel to segment CD, and that segment TE is congruent to segment DE, and we're going to prove that segment AT is congruent to segment CD. Okay, because remember, just because something is parallel doesn't mean they're congruent, right? Just because something is parallel doesn't mean it's congruent. So last time we took about 4 minutes. So I'm going to give you guys. Remember, the first thing we need to do is prove the triangle is congruent. And then the second thing, there's no mistakes in this one, I promise. Okay, so the first thing you're going to do is prove the triangle is congruent. And then you're going to use CPCTC, right? So you should already know your last line, right? It's going to be segment AT is congruent to segment CT by CPCTC. So what's more important is how do we get there? Okay, so we get 4 minutes. Here we go. And if you have questions, let me know. Oops, sorry, I sent that to the wrong person. All right, so there isn't a lot of time left in class, so I'm going to do this, and then I want to show you how this applies to real world, okay? So let's go through this, and then if you guys have quick questions, you can stay after a little bit, and I can go through this with you. So the first thing I'm going to do is update my picture with my givens. So AT is parallel to CD, right? So we add that little arrow, okay? And then we also know that TE is congruent to DE. Okay, so those are my givens. Now remember, parallel doesn't mean congruent, okay? So I know that we have to prove triangles congruent using SSS, SAS, ASA, or AAS. And all I have now is a pair of sides, okay? So, and I know that I'm going to have to prove sides congruent. So the first thing is I don't have midpoints, I don't have reflection, reflexive, so I'm probably not going to do that. But what I do see, and like what we had on our last one, is it's a bow tie problem. So first thing that I see is that we are going to have vertical angles. So I'm going to start off with that. I'm going to say angle AET is congruent to angle CED, and that's vertical angles, right? So that's just like the last one we did. So I hope you guys got that one, right? Because it's the same thing, right? So we have, what do we have now? We have a pair of sides, a pair of angles. So it looks like we can get a couple of this. So I either need to get another side or another pair of angles. Well, we haven't used the parallel line yet. So with parallel line, we have corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior. But the first thing I want to point out is all of these angles are on the inside. So it's not going to be alternate exterior. So we only have 3 choices, right? So there's 2 angles that are on this parallel line, angle D and angle C, and there's 2 angles that are on this line, angle A or an angle T. So depending on which one we choose, our proof is going to be slightly different. So for example, if I pick A, right? So if it was corresponding, do you see how A is kind of on the upside of this transversal? Well, upside would be on the outside, so it's not going to be corresponding. So that leaves only one left, and that's alternate interior. So if I choose these 2, so that is angle A is congruent to angle C, right? Because we have if parallel lines, then alternate interior angles are congruent. Okay. Then I would have, right? So in this case, I would have the side is only touching one angle. I would have angle, angle, side, right? Because the side is only touching one of these angles. But if I had picked T or D, right? If I had done alternate interior with T or D, then I would have had angle, side, angle. So there's more than one way to do this proof. So again, I picked angle A and angle C to be alternate interior, but you could have also picked T and D, and that would change which one of these you're going to use, okay? So in my case, the S is only touching one angle, so I'm using this one where the S is only touching one angle. So I'd have triangle AET is congruent to triangle CED, and that is by, in my case, AAS. Now remember, if you guys are struggling with these properties, the very first thing we did in this trimester was to write down all those properties. So they should be all in one place in your notes, and you can just process of elimination get that. So then at the very end here, I say, okay, hey, if these triangles are congruent, are corresponding sides congruent? Heck yes, they are, right? It is congruent to CD, right? And that is by CPCTC. All right, I had to go through that a little bit quickly because I do want to do one more thing with you guys. Okay, so if you have questions about this, just stay after a little bit and I'll help you guys out, okay? All right, so the last thing is like, hey, why are we learning this? Why are we proving triangles congruent? Well, there's a great example of this. Now, there's going to be a better way in about a month to do this, but this is a pretty ingenious way. So let's, for example, say we're looking at the Skagit River. Now, if I wanted to measure the length across the river, right? Let's say I want to know the distance across the river. You're not just going to hand someone a tape measure and be like, oh, go to the other side, right? That's dangerous. You're not going to swim across the Skagit River, especially when the water is going really quickly. You can get sucked under, right? Don't do that. Should you put this in your notes? Absolutely. Why not? Anything you do, we should put it in your notes. Okay, so the Skagit River right here. So we have this task. We need to measure the length of something that we can't, right? That we can't measure traditionally. So it's this method called indirect measure. So what you do is you start by finding a point on the opposite side. So maybe that could be a tree. I'm doing the broccoli approach to trees. Okay. So you pick a point over here next to the tree. We're going to call this point T for tree. Okay. So you just find a point on the opposite side of the river, hopefully really close to the riverbed, right? Then, now, to do this, now, if you were like professionally doing this, you'd get like a tripod, right? You'd get like a tripod, and then you'd put a little point right there. Does that make sense? So that's how you do this if you were professional. You just get a little tripod. Like, you ever seen those guys on the street with the little tripods measuring stuff? Okay, then you'd want to come perpendicular all the way across, and then have your start point A. Okay, because this is going to be your distance, right, that we're trying to find. Then, to do this, you measure some known distance this way. So, for example, I am going to start at A, and I'm going to make it perpendicular, and I'm going to go 10 feet. Okay, and the reason why I chose 10 feet is because then I know my midpoint is at 5 feet. Okay. Now all you have to do is you have to walk backwards from point B until your line of sight goes like this. It lines up with the midpoint and what you're looking at. Okay, so you set up your tripod here. Oops. You set up your tripod here so that your line of sight goes through the midpoint and touches your point that you're looking at. Because what you get here, then, didn't we just create vertical angles? And what you have here, right, if this is 90 and this is 90, you have angle, side, angle. Angle, side, angle. These two triangles are congruent. And this is really easy to do. Oh my gosh, it's way cool, guys. So what it turns out is this distance right here, this distance on land, you can measure this with a tape measure. And then now you know the distance across the lake. And this is called indirect measurement. Now, you can measure all sorts of stuff with this. You can measure the height of buildings. You can measure the height of mountains. Now, the problem here is with congruent triangles, this side can get awfully large for big things, right? So there's got to be a better way. And in a month, we're going to learn about similar triangles and to do that. So I just wanted to show you guys, I know sometimes math is kind of boring, but it can do really cool stuff. Okay? So before you guys leave, just really quickly, if you have questions, stick around just for a little bit. Remember, you do have a homework assignment. I am so sorry. Get that done as soon as possible. I'll send reminder emails at the end of spring break. Also, a lot of you guys are missing a lot of assignments. It is 80% of your grade. Use this week to get your assignments in. Get to 100%. There is no penalty for late work. Okay? Please get it done. And with that,